This is section 8.1, part 2, where we are going to be adding and subtracting polynomials. Couple of examples that are not in your packet. These say combine like terms. When we combine like terms, we are adding or subtracting the coefficient, meaning the number in front. So 3x minus 2x is 1x. Letter B, negative 5x squared plus 9x squared is 4x squared. Letter C. And letter D. Letter D looks a little bit crazy, and there are exponents everywhere. The exponent rules that we just finished, we only dealt with multiplication. Think back for a moment. When we did exponents, we were doing problems like this that had multiplication. I understand that when you were multiplying like bases, you were adding the exponents, but you didn't actually see addition anywhere in the problem. The problem that I have up at the top of this slide in my handwriting, and the slide lettered problem D, are very different problems because of the symbol in the middle. Here, all we're doing is combining like terms. There are negative 7 of these things and 15 of these things, so that means there are, I don't know, how many of these things? There are positive 8, x squared, y to the thirds. All right, now these are in your notes, and there aren't very many examples in your notes. It says add or subtract each polynomial. You must write your answer in standard form from here on out. So every answer must be written from highest exponent to lowest exponent. When you do these problems, you can do them either vertically or horizontally. It is completely up to you. Some textbook problems will be written vertically, some will be horizontally. They're completely interchangeable. So for the first one, notice it's addition. So I'm going to start adding my like terms. I have an x squared term, I have a plain x term, and I have a term with just a number. I'm going to add them in standard form so that my answer is in standard form. So if I take 6x squared and add it to 2x squared, I get 8x squareds. If I take my positive 3x and add it to my negative 6x, I end up with a negative 3x. And then, I gotta erase to see this, I have a positive 7 added to a negative 4. So 7 plus negative 4 is a positive 3. My answers are written in standard form because my exponents go from highest exponent down to lowest exponent. All right, let's try letter B. Letter B is a subtraction problem. Please notice that it's in vertical form, meaning that it's stacked on top of itself. Think back to first grade, second grade when math was fun. Everything was always written vertically. And then at some point when you got a little bit older, things shifted horizontally, but the answer was still the same. What's nice about vertical is that you're able to line up all of your like terms so that it takes away some of the guesswork. Just be careful, these here, they're not like terms. But these two are. So I'm going to put a red box around this one so I keep it separate. And I don't know, do I have a different color? Black kind of squiggle under here. I'm trying to get it to show that they're different terms. All right, so let's go ahead and subtract. I have circled here in blue x to the thirds, but these are being subtracted. So it's 2x to the third minus 5x to the third. I have nothing to combine the 4x to the squared with, but if you notice, I have to take 4x minus nothing, still 4x squared. I have this term that I underlined here. I have to take no x to this first term, so 0, because there is no term there, and subtract it from 2. And then lastly, what I have circled here in green. So it's a negative 6 minus a negative 2. I have another way that might make this make a tiny bit more sense. I'm going to rewrite the problem. I'm going to add in a 0x to represent the term that really isn't there, minus now they're vertically and they're all lined up. So 2 minus 5, 4 minus 0, 0 minus 2, and a negative 6 minus a negative 2. Notice my answer is in standard form because the exponent goes 3, 2, 1, none. This one lays really nicely because it does march 3, 2, 1, none, but as long as they're highest to lowest, it's also going to be in standard form. All right, couple more examples. Letter C. This is another subtraction problem, and these ones can be a little bit tricky. I'm going to find my like terms. This is a 1v to the third minus 9v to the third. I'm going to take my v squareds. This is a 6v squared minus a negative 7v squared. So minus a negative becomes a positive. I have a negative v minus v to the third. I'm sorry, minus 3v. And then lastly, there's no plain number over here. So think about this problem. There's no constant. So if I take nothing minus negative 2, it's going to give me a positive 2. The answer will work out the same whether we do it horizontally like I did in letter C or vertically like I did in letter B. The biggest and the hardest part is just keeping track of that negative. Go ahead, pause the video, try letter D, and try letter E. How'd you do on letter D? This problem was addition, so it should have been the easier of the two. I had nothing to combine the w to the third with, so it was just 9w to the third. 8w plus negative 2w gave me a 6w, and I had nothing added to a negative 5, which gave me negative 5. Letter E was a little bit harder, so what I tried to do was I tried to stack it up vertically so that you can see it, but I want to walk you through it horizontally as well. I have 1 squared minus, 1d squared minus 5d squared. So 1 minus 5 is a negative 4d squared. I have an 8 minus 3. I have a negative 5 minus 1d. But then I have this term here with nothing to go with. So I have nothing from over here with a d to the third minus this. So nothing minus a negative 2d to the third gave me a positive. And then I'm going to put it in standard form. What I did while the video was paused was, so where's my work? Kind of stops right here. I put everything in order and I lined up my d to the thirds, my d squares, my d's, and my constants. And I recognized as it's in blue that there was no d to the third in the first equation or the first expression. So I put in a 0 and then I subtracted vertically. Either way, should give you the exact same answer. One more problem. It says write an expression for the perimeter. Write your answer in standard form. Well, what's perimeter? When we think of perimeter, we should think of around a shape. It's the fence. So we have to add up everything around the shape. Since this is a rectangle, I know that the value of 5c plus 2 is also the same on the other side. 9c minus 10 is also the same on the top. So I have 4 things that needed to be added up. I have a 9c minus 10. I'm going to add it to a 5c plus 2. I'm going to add it to the other 9c minus 10. And I'm going to add it to the 5c plus 2. And what we end up with is a huge combining like terms. So 9c's and my 5c's added up is going to give me 28c. And if I add up all of my constants, grab your calculator if you'd like to, a negative 10, a positive 2, a negative 10, and another positive 2 gives me a negative 16. Homework should be out of the book. Problems will be given to you in class. Good luck, and please remember to ask questions if you have them.